Hello everyone, here is your teacher Neha, and in today's video I am going to explain you the concept of hybridization. So before starting, those who are new to my channel, please subscribe, share and like to get notified of the further videos, upcoming videos. Okay, so let's start today's video, that is hybridization. Now, hybridization is the mixing of atomic orbitals of the same atom. The atomic orbitals must belong to the same atom. Okay, but they have slightly different energy. These atomic orbitals mixes to generate new atomic orbitals which have equal energy and identical shape. This is hybridization. Hybridization can be defined like this. To understand this concept, let us go to flashback and take the example of carbon. Now, the covalent bond is formed by the overlap of half-filled atomic orbital according to valence bond theory. Valence bond theory says that the covalent bond is formed by the overlap of half-filled atomic orbitals, and the covalency of the element should be equal to number of half-filled orbitals present in the atom of that element. Right? Now, see, take the example of carbon. Carbon, its atomic number is 6 and the electronic configuration you can write as 1s2, 2s2, 2p2. 6 electrons. More clearly, you can write here 2px1 and 2py1. Okay, since p subshell has 3 orbitals, so 1 electrons in each orbital. This is the configuration of carbon. Now the carbon has only 2 half-filled orbital, partially filled orbitals, so the covalency of the carbon must be 2. Okay, but we know that carbon is tetravalent. That means it is showing valency of 4. To overcome this problem, it was suggested that this 1 electron in the completely filled valence shell, completely filled valence orbital, this 1 electron becomes unpaired and jumps to the empty orbital. Empty orbital, that 2pz. This one is empty. Empty orbital and without consuming excess amount of energy. Okay, so what the configuration will become then? 1s2, 2s2, 2p1, 2px1, 2py1 and 2pz1. Okay, this will be the new electronic configuration of carbon after 1 electron from this 2s orbital jumps to 2pz. Okay, so the previous configuration is the original configuration, which is known as ground state. It is ground state, and the configuration after 1 electron get excited to the new orbital, it is known as excited state configuration. This is called excited state configuration. Now you can see that the carbon has 4 partially filled orbitals and it can form now 4 chemical bonds with other atom. Now carbon can be tetravalent in nature. Now it uses 1s and 3p orbital to overlap with the half-filled orbital of the reacting atoms, forming 4 covalent bonds. But the covalent formed by the 2s orbital of carbon should differ in energy from the bond obtained by this p orbital. Okay, however, the experimental data clearly shows that all the 4 bonds of the carbon are of same energy. And moreover, the 3 bonds formed by 2p orbitals should be at the angle of 90 degree. They are oriented perpendicular to each other, p orbital. So the bond formed should be at the angle of 90 degree. But this is not actually so. Hence, the new concept was introduced to explain the abnormal behavior of these types of atoms, like carbon. Okay, and according to this, all the 4 orbitals of the carbon having unpaired electron, these 4 orbitals having unpaired electron and possessing slightly different energies will mix up their energies and then redistribute in 4 equal quantities, thus giving rise to 4 new orbitals, each having same amount of energy, right? And this is known as hybridization. Okay, so what happens if you write the previous, this is the excited state configuration of carbon, and after mixing up you can represent it with a dotted line. This shows the hybridization, that means these orbitals are mixing up to redistribute their energies, or you can also show like this. This also shows that hybridized orbital, and since here 1s and 3p are hybridizing, mixing, so the hybridization here is sp3. This is sp3 hybridization, right? So I will make a next video on the types of hybridization. Till then, keep learning with me, and that's all for today. Thank you.